All right, so now we're going to define the sector of a circle. Before we define it, let's go ahead and draw it. It's boom, boom. All it is, it's the area of a portion of a circle, but it's bounded by two radiuses. Radiuses, who really knows? And an intercepted arc. So it's basically just a pizza slice. Did I put an E on the end of arc? Oops. Just think of a pizza slice. Alright, so this is the formula to find the area of a sector. It's going to look very similar. It's going to be central angle over 360 equals sector area over pi r squared. Alright, now realize, let me do something. Pi r squared, that's a fancy way of writing area. So again, I could write this as central angle over 360 equals sector area over area. Remember, this is just a portion of degrees over all the 360 degrees. Sector area is a portion of the area over the whole area. Alright, and just so we're clear, CA means central angle, SA sector area, and then if you A is just regular area, R is radius. Alright, so this is the new stuff. Alright, looks very similar. So, and then just for fun, old stuff, we're not going to go too in depth, but this is what we're doing for arc. Arcs, we had central angle over 360, and notice how arc length was over 2 pi r, or pi times diameter, or circumference. Alright, that's the old stuff. This is the new stuff. We're gonna go back and forth between them, so you have to know which one to use when. Alright, so all we're gonna focus on the rest of these notes is finding sector areas. Alright, so literally all you do is you're gonna write central angle over 360, a part of the total 360 over the total 360. Sector area is a portion of the area over pi r squared. And then we're going to plug in what we know. So basically we want to find a fourth of the area for this. Alright, so plugging in all that junk, I'm going to get 90 over 360. Sector area, I'm going to be lazy and change to x. 90 over 360. 90 goes into 360 4 times. Cross multiply, divide both sides by 4. And that's it. Alright, remember, exact answer. And then I can plug this into a calculator. I'm going to guesstimate 7.5-ish. Let me see. Ooh, I'm so embarrassed. 7.1-ish. Alright, that's it. So the area of the sector was 9 pi over 4, which is approximately 7.1. Alright, this one over here, a huge sector area Again, let's write out the formula. Let's not get lazy. Again, writing the formula each and every time is going to help me remember all the parts. Central angle is 300 over 360. Sector area is what I'm finding. And then the radius is 19. Alright, so some simplification I'm going to do. Remember, the zeros just automatically cancel. And then again, sometimes fractions can be a little difficult to simplify. Just realize, when in doubt, if they're both even, take out take out 2. Alright, I can divide 30 by 2, get 15, 36 by 2, get 18, and now I can actually take a 3 out of both of them. I can take 5, I get 5, 6, and that's it. Alright, so after I reduce this, I have 5, 6 equals x, and I think this is going to be 381, but let me just double check. 361, I mean. 361 pi. Okay, from here, cross multiply, I'm going to get 6x, 5 times 361, 1805 pi. And this is a huge number. And then divide both sides by 6. I'm going to get x equals 1805 pi over 6, and that's exact, and that's about 945.1. That one's a little tough. Hopefully this next one's a little easier. Alright, this one, let's see what we got here. Central angle over 360 equals sector area over pi r squared. So the central angle in this case is 270 over 360. Sector area is what we're finding, and pi 6 squared. Alright, working on reducing this bad boy over here. Boom, boom. 9 actually goes into, I can simplify this. 9 goes into 27 3 times. 9 goes into 36 4 times. So boom, the 9's cancel. So I'm just left with 3/4. And that's going to equal x over 36 pi. So really I want 3/4 of the area. That's how I can interpret this. Boom. 4x. 3 times 36 is 108. So x is going to be 27 pi. Again, make sure we read the directions exact. If it wants directions, keep it as that. If it wants approximately, it's about 84.4 or 84.8, and that's the rounded answer. Alright, and as you're feeling better with this, maybe you try this problem on your own, then you compare answers to mine. But it's literally just the same thing. Repetition's pretty important. Central angle equals sector area. Central angle over 360 equals sector area over pi r squared. 60 over 360. Call sector area x because that's what I'm finding now. 60 over 360. 60 goes into 360 6 times, so that reduces to 1/6. And then x over 100 pi, cross multiply, 6x equals 100 pi. Divide both sides by 6. 50 pi over 3, because that reduces to that. This is about 52.4. Alright, so just a bunch of sector area problems. Alright, again, it looks daunting, it looks kind of a crazy formula, But once you plug in everything, isolate the variable you need to solve for, it's really just cross multiplying. And if you, some people prefer exact answers, some people prefer rounded answers. Really just simplify, utilize your calculator, and know how to keep it exact or rounded when needed. All right. Really not that bad. It looks scary. This is just something you got to practice a lot, and you guys can easily get good at it because I know you guys are really smart. And then math behind the pizza. That's what we're going to end on. The area of a circle and sectors. All right. What's your dog's favorite kind of pizza? Well, pepperoni, of course. Ba-doom-tsh. All right. Have you ever done math to calculate how you can get the most food for the least amount of money? Well, I'm sure we all do this, whether it's at Cane's, Habaneros, or even Chick-fil-A. All right. Today we're going to do this with some of my favorite pizza places. And an underrated pizza place is Luigi's right there by Scioto Darby. It's been open forever. No one's ever in there, but it's good pizza. All right. You are starving and you want food fast. You go to Luigi's on Cemetery Road for $14.75. You get a delicious large pepperoni. The pizza has a diameter of 14 inches and cut into 10 slices. Like all normal people, while you're stuffing your face with pizza, you begin to wonder about the math behind the pizza. You start to do the following calculations as you eat. All right, so let's just extract some air. It told us that the diameter was 14. All right, the central angle, there's 10 slices. So each pizza has a central angle of 36 degrees. All right. So if the diameter also is 14, that means the radius is 7. All right. So those numbers will help us move forward. So what's the area of the pizza? The area is pi r squared pi 7 squared 49 pi. All right. What is the area of one slice of pizza? Parentheses, area of a sector. What is the area of one slice of pizza? The area of the sector. All right. So remember, that's going to be central angle over 360 equals sector area over pi r squared. We know the area already, though. Boom. It's just 49 pi. You know the central angle is 360. So really, after I plug in stuff, that's what I get. So basically, we just need 1/10 of the area. All right. That simplifies to 1/10. Cross multiply. I'm going to get 10x equals 49 pi. Divide both sides by 10. And x, we'll keep it like that for now. Actually, let's do it like this. All right. The area of the pizza, let's get all decimals. 49 pi, 153.9. So it's about 153.9 inches squared. Which one slice of pizza, it's kind of weird to think about this, as inches squared, is 15.4 inches squared. All right, and how much did you pay for that one slice? Well, remember, the whole pizza was $14.75, so that one slice of pizza cost you $1 and about 48 cents. We had to round up. All right. So think about that. Just some life questions, all right? Some philosophy. Is 15.4 square inches of pizza, is that worth $1.48 to you? To me, that is, all right? That's a great deal. All right, I'll take that deal any day of the week. All right? And then just one last fun fact before I let you guys go. Taking on a serious issue, this is actually a true fact. One 18-inch pizza is more than two 12-inch pizzas. Gasp. All right, stay tuned to find out.